Now the bench is a pretty substantial thing. You need a vise that you can put the saw in that is straight, it doesn't wobble. You can tilt it to do various aspects of the filing process. It needs to be a good height. The height that I like is to have the top of the vise about elbow height when I've got my elbow bent at a right angle like this. You need to have very good light, especially for pointing up the cutter teeth, because you'll need to be able to see reflections off of those teeth. And the reflections that we're talking about are quite minute, so you need very good light. And traditionally, the filing room was set up so that you have, facing the filer, you have a bank of windows, generally facing north, so you get good diffuse skylight. And often they'd end up also having true skylights that illuminate from the top. If you don't have a situation like that where you have a good north-facing skylight, what you can do as a substitute is use like an 8-foot fluorescent light or 2 4-foot fluorescent fixtures and put them up on the wall, say 7 feet off the deck or off your floor, so that the light comes in at a nice angle to be able to reflect off of the flat spots which are created by the jointing process, which is what I'll talk about next. One of the things that you may notice about this bench is that there are a number of holes that I have drilled in here, and the purpose of those is to be able to adjust the height of the saw to hold the saw at a particular height. What I do is in each of the holes I just put a 3/8 inch bolt, and there are some operations that I want the saw fairly high like this, and there are other operations that I want to be able to have the saw lower in the bench like this, and so I use the bolts to hold that. Another reason for using something fairly substantial like these bolts is that when I swedge the saw, which is another one of the processes I'll be describing here, you're hammering on the saw and you need something to keep the saw from being driven down into the bench. I hold the saw with these thin oak slats that are tensioned so that they hold the saw firmly, but at the same time they don't hold the saw so tight that I can't lift it in and out, or if I need to move it sideways like that. Another thing that you may notice on this bench is that I've got black tape on the top of this, and that is so that I can see the light that's coming off of the teeth better. It gives me a better contrast between the light that I see on the tips of the teeth and the background, which enables me to see the progress I'm making on the tooth better. You know, it's good to have a tool tray where you can put your various tools. As you can see, you've got quite a number of different tools to use. Now, the orientation of this bench for most of our operations will be vertical like this. When you joint the saw, when you fit the rakers up, and when you set them, but when you're actually pointing up or sharpening the cutter teeth, then the bench will be tilted at probably around a 45-degree angle, something like this. It's much easier to file a bevel on the tooth, and also with your light source coming in at say a 45-degree angle and hitting those flat spots that were created by the jointing process, it makes it so that you can see the reflection off of the tips of the teeth much easier. And this is very critical to be able to clearly and distinctly see the flat spot on the tooth that was created by the jointing process. Before we actually go into the section on adjusting tools, we need to talk a little bit about why we're adjusting the tools to the adjustments that we are making. The adjustments on tools will be a function of a number of different things, including the type of wood that we're working with, the weight of the saw, the size of wood. All of these have an effect on the adjustment. And in the final cut, how you adjust the tools is going to be a function of how well your saw is working in that particular wood in that particular situation. But I can give you some rules of thumb here. For a felling saw, which is a fairly light saw, the way I end up adjusting the raker gauge is such that the rakers are about 12/1000ths of an inch shorter than the cutter teeth. And I use the same numbers with the spider. I set up the spider to where there's about 12/1000ths of an inch clearance between the spider and the flat that I'm using to gauge it by. Now a heavier saw, like this bigger bucking saw, I'll use quite a different raker depth. Instead of using the 12/1000ths like I did with the felling saw, I'll adjust my rakers to where they're about 16/1000ths of an inch shorter than the adjacent cutter teeth. And the weight also affects how much set you put in it. Rather than the 12/1000ths like I would put in with the lighter weight felling saw, I put about 16/1000ths of an inch set in the cutter teeth. You know, that's a good starting number. The real test is taking it out and putting it on a log and actually running it. And if the saw binds, it means you don't have enough set in it. If your saw pulls shavings with whiskers on it, and we'll talk about that later, you know your rakers are a little bit too long. If the shavings are real thin and papery, it means that your rakers are actually cut too short. There's three primary tools that we're working with in filing a saw. One is the pin gauge, another is a raker gauge, and the third is the spider, which we'll talk about here in a bit. I'll talk about how to adjust the pin gauge first. The pin gauge, we have a pin right here, and that sticks down below the level of these two plates here a certain distance. And for a good average crosscut saw, what I'll do is adjust this pin so that it sticks down below the level of these two plates by about 9/1000ths of an inch. Now, how to get 9/1000ths of an inch there's various ways of doing it, but one fairly easy way, if you don't have any other measuring tools besides a feeler gauge, is to actually use a saw tooth. Now I have a tooth here which has been prepared for swedging. The height of it is about the height of the two cutter teeth on either side of it. And so what I'll do is I'll swedge that tooth over to where it's about 9/1000ths of an inch below the straight line between your two adjacent cutter teeth. So I'll just go ahead and swedge it over some. And then I need to measure the height of that. So I'll do that with a flat piece of steel and a feeler gauge. I'll put the feeler gauge on there, put the flat on the two teeth adjacent to the raker, and see how much I've swedged it over. Well, the raker, or the feeler gauge, is still the tooth is still so high that the feeler gauge is hitting the tooth. So I'll need to swedge the tooth over some more. Okay, I've got a tooth here that I've now swedged over to 9/1000ths, to where this raker tip is 9/1000ths of an inch shorter than the line between these 2 points here. And I can test that by putting the 9/1000ths feeler gauge between my flat, and it just clears that raker tip. Now I use this as a reference to check to adjust the pin gauge. So what I'm doing now is I put the pin gauge on here and I adjust the height of the pin as I move it back and forth until it just hits that raker tip. So now I know that the pin is adjusted at 9 thousandths. Now while I'm holding the screw tight, or the pin, I lock this down so that it doesn't move. I test it. Well, it moved up a little bit, so I need to screw this down just a hair so that it touches the tip. There. Okay, that's just barely touching the tip of that raker. Now I lock it down tight and make sure that it doesn't move anymore. I can just barely feel that touching. So now we have the pin set at 9 thousandths of an inch below the two support plates. The raker gauge that I used on this saw was one that I'd built myself, and there aren't very many of them around, but I'll show you how to adjust that, because the adjustment process for this will apply also to other sloped filing plate raker gauges, of which the Anderson gauge is an example. The plate that I actually use to adjust or to dress the raker point on a slope filing plate raker gauge obviously has a slope to it like this. So in order to adjust my raker gauge using the raker tip which I had originally used for adjusting the pin gauge is fairly easy. We've swedged this raker tip over to 9 thousandths so that the pin gauge will just clear it. Now, the raker gauge should be adjusted about 3 thousandths below what the pin gauge is adjusted. So I can adjust my raker gauge by putting the raker gauge on the saw just like I would use it. And I'll take two pieces of 3 thousandths feeler gauge, put one under one side between the support plate and the adjacent tooth, and another one under the other side. Now, if I adjust the height of my raker gauge here to where the file just touches the tip of that tooth, okay, we're not touching there. I'll drop it down just a little bit. Okay, that's too low. So I adjust the height of my filing plate until the file just touches that raker tip. I'm doing this primarily by feel. Okay, it's not touching there, so drop it just one notch. Okay, we're just barely touching that tooth. Now I know that the raker gauge filing plate is adjusted to where it's 3 thousandths of an inch below where I have the pin gauge adjusted. And that's just what I want, because when I'm using the raker gauge, I'm putting it on the tooth, on the raker tip. I want to make sure that there's enough of the raker tip sticking up above the filing plate that I can file it off and dress that tooth the way it's supposed to be. Now, the Anderson gauge essentially is the same thing. You put that on the tooth, you put the feeler gauges underneath the plates, and there's a little screw in the top of the plate that you can use to move this plate up and down, and you use exactly the same process of running the file across the filing plate until it just barely touches that tooth. and you know that the filing plate is adjusted for being 3/1000 of an inch below where the pin gauge is adjusted for the swedging purposes. Now, the most common raker gauge that you'll run into is one like this. It's called a Morin gauge. This particular gauge and many similar to it have a flat filing plate on it, and this gauge here is quite easy to adjust. The filing plate on it is held on with 2 screws so that you can undo these 2 screws, loosen up the filing plate so that it moves, and then to adjust it, all you have to do, if you want your filing plate to be adjusted for 12/1000, all that's necessary is to put a piece of 12/1000 feeler gauge between the filing plate and the rail, these 2 rails or plates here that rest on the teeth, and then tighten the filing plate back up. And so doing means that the filing plate will be the thickness of the shim below your 2 adjacent cutter teeth, and automatically adjust the proper height of your filing plate. There's another gauge called a Simon's gauge, which actually has a ramp that the filing plate moves along. So that as you move the filing plate up or back and forth, the height of the filing plate changes, and the adjustment is very similar. You can put a piece of 3/1000 feeler gauge on the top of each of the adjacent cutter teeth and adjust the filing plate back and forth until when you go across the filing plate with a file, it just touches that